This is Professor Miller, and I'm going to solve a couple of problems about the normal distribution. So, look this up online. The length of songs has a distribution that's approximately normal with a mean of 235 seconds, a little shy of 4 minutes, and a standard deviation of 39 seconds. What percent of songs last more than 210 seconds? First thing is to draw the bell-shaped curve. The mean goes in the middle. That's on the x-axis. X represents the song length in seconds. We want the probability of more than 210. So 210 is less than 235, goes to the left. We shade in, it says more than 210, we shade in above that. That's going to be very important when we work this out. Next step is to convert this to a z-score. And the z-score scale, 0 is in the middle. So it's just like using a different ruler, where everyone uses the same ruler for their normal distribution. 0 goes in the middle, and we need to find the z-score for an x of 210. Most important formula in this course is what I call this. Z is x minus the mean over the standard deviation. 210 minus 235 is going to be negative. Divide by the standard deviation of 39. Negative 25 over 39. That's going to be about negative 0.64. That is the z-score for this 210. Notice it's negative to the left of 0. Okay. I did it in Excel. I didn't use that number because I worked it out in Excel. I created this little file I call my z-finder. And in that file, I put the x, the mean, the standard deviation, and I have this formula here in this cell. You can see the formula there, C5 minus E5 divided by C8. I always keep this file handy so that I can compute z-scores as needed. So I just put in the mean, put in the standard deviation, and then for any x value I type in, I'll have the z-score. And I have the area associated with that z-score here. You use the norms dist function in Excel. That gives you the probability of getting a value to the left of this z-score. So the area is 26.07%. Let's go back to see what. So this area, look where I put it, is 26.7. That's from the norms dist function. Now notice that that's not what we want. We want 1 minus 0.2607, 100% minus 26%, about 74%, 73.93. Okay, and now that's the answer. That's this area. Don't always do that. It depends on the diagram that you're doing. So if you want to write this out, the probability that x is greater than 210 is the same as the probability that z is greater than negative 0.64 and 1 minus 2607. That's part A. Part B. Find the 95th percentile. I call this the normal backwards. We'll start out the same way. Draw the normal curve. 235 goes in the middle. It's going to be some value much higher than 235, right? 235 is the mean, also the median by the symmetry. We want the 95th percentile. Well, the mean is the 50th percentile because of the symmetry. So we want some value that's pretty far to the right of 235 on this x-axis. First thing we'll need then is the next thing we'll need is the z-score, such that 95% of the area is below that z-score. In Excel, that's found using norms inverse. So again, in my z-finder, I have that set up so that when I put in a percent here, it will compute norms inverse there. Norms inverse of what's in this cell, which is 1.64. And I set up this template that does the x value for that. So I want to be 1.64 standard deviations above the mean. So I did norms inverse of 0.95, got 1.64, that's how many standard deviations above the mean, and now we'll use the most important formula in this course turned around. X equals the mean plus z standard deviations, that's 235 plus 1.64 times the standard deviation was given above there at 39 seconds. I get 299.14 minutes. It's a good idea to put that back in the diagram, make sure it makes sense. Like if you got a value that's less than 235, you know that something's wrong. That's part B, normal backwards. Part C. Notice how similar it is to part A. It's still 235 is in the middle, and we're trying to find the probability of getting above 210. But we're not going to get the same answer. Because this is not the probability of getting one song above 210. It's the probability of getting a mean for 23 songs. One difference is the way I'm going to label that axis. It's not x anymore. It's x bar. So if everyone were to go out and take 23 songs, find the average length of their 23 songs and bring it back, it would have a normal distribution according to the central limit theorem. The mean of the distribution would still be 235, which is the population mean. The mean of the sample means is the population mean. The difference is the standard deviation. There is less variation in the distribution of sample means of size 23 than there is in the population, which has a standard deviation of 39. The difference is a factor of the square root of 23. Okay, so 0 is in the middle. What's going to change is the z-score. So the most important formula in this course, x minus the mean over the standard deviation. Uh-oh, can't use that. This is x bar down here. Oh, okay, I'll fix that. Put an x bar, right? Not so fast. Also need the square root of n. Okay. Interestingly, if you compute that, (39 over the square root of 23), it's going to be quite a bit like the one we got before, negative 25. What I recommend is thinking of this as division by a fraction. You might recall to divide by a fraction, you multiply by its reciprocal. There, you see the z-score for part A right here, and it's going to be bigger by a factor of the square root of 23. If I change this and divide by the square root of 23, if you're setting up a template, you can just put n equals 1 here and put that as part of your formula in general to compute any z-score. And then for this case, I would change it to n equals 23 and compute the z-score. It is now negative 3.07. Negative 3.07. Find the area associated with that. What Excel is going to tell me is that area is very small, 0.001055, and 1 minus that is going to be almost 100%. This part is 0.00105. To get this part, we'll do 1 minus that. And our answer here is 0.9989. Almost a sure thing. All right. Very close to doing what I call real statistics here, inferential statistics. So suppose you knew these values for the distribution of all songs, and you had this theory that songs that come out in July tend to be shorter than the average song. Pop songs come out and they're really short. So if you took a sample of 23 songs that came out in July and you got a mean of 210 minutes, you would say, hey, that is weird. The probability of that happening for any 23 songs is less than about 1/10 of 1%. Very, very small chance of that happening just at random. Therefore, there must be something special. It must be because I took all songs coming from July. And we would say that that's a statistically significant difference. So that's how we're going to use this to do statistical analysis and to do research experiments. Use the statistics that come from the central limit theorem. That's all, folks.